Okay, today we're going to address the slope-intercept form. As I said, the first couple lessons in this unit are going to be review for the most part. We reviewed them briefly at the beginning, and now we're going to review them briefly within the context of Unit 3 here. So, getting right into slope-intercept form, we will watch this short clip first, so listen up here.
Jose Bautista led Major League Baseball in home runs during the 2011 season. After 82 at-bats, he hit 9 home runs. After 321 at-bats, he hit 31 home runs. How many home runs would you predict Jose Bautista to hit after 500 at-bats? In this lesson, you'll learn how to write a linear equation in slope-intercept form, given a graph or other information, and how to use the equation to answer a question like this. You'll also learn to graph linear equations written in slope-intercept form.
Okay, so this gives you a little idea of some things that this stuff is used for. Extrapolation, trying to figure out what will happen later on. So let's go ahead and dig into the guided notes, which is right here. Okay, so first off, we're going to talk about graphing. Hopefully, again, the majority of this will be review. Remember, the slope-intercept form of a line is written as y equals mx plus b. That should not be an issue for us at this point, where m is our slope and b is our y-intercept, right? It can also be written in function notation. And at this point in time, we should be familiar enough with function notation. Quite simply, all we do is replace y with f of x, and that indicates to us that this linear equation is in fact going to be a function. It will pass the vertical line test, right? Remember, the only line that is not a function is in fact a vertical line. One thing I want you to remember through this lesson as well is if you're given this data in the form of a table instead of a graph, you always have to make sure that that table has a constant rate of change, because it has to have a constant rate of change in order to be linear. Okay? So again, you should be able to identify the pieces of this slope-intercept form. M is our slope. B is our y-intercept. And remember that y-intercept occurs at a point where my x value is 0 and my y value is whatever that b is. If it's positive, we go up for that b. If it's negative, we go down for that b, right? So here's just a little illustration. Y equals mx plus b. We have a specific point on here that is our y-intercept. Notice I did not go right or left anywhere because I need to be on the y-axis. Therefore, the x value there is 0. It's always going to be 0 of that particular point. And my y value is this b right here. Okay? So let's talk about graphing these lines. To graph a line in slope-intercept form, we are going to, oops, I should have erased these from your there we go. I'll do that. Okay, now we're going. Okay, so let's graph a line in slope-intercept form. The first thing we're going to do is identify the slope and the y-intercept. Well, that should be easy enough. It's simply recognizing two numbers, right? The next thing we're going to do is plot the y-intercept at 0b. Then we're going to plot another point by using the slope. We're going to count by counting the slope. And remember, what we had a problem with this before is that people were always counting the slope from the origin, when in fact you should be counting the slope from the y-intercept. Okay? And then we just draw the line. So let's go through these examples right here. Graph the following. Y equals 3/2 x minus 4. Well, should be able to identify right away. The slope is 3/2 and the y-intercept is -4, which means there's a point at 0, -4. And when I go to graph that, I have a point at 0, 1, 2, 3, 4, right there. And then if I use the slope 3/2, that means I need to go up 3, 1, 2, 3, and over 2. Notice I counted that slope from my y-intercept. And then I can count again if I wanted another point, up 1, 2, 3, over 2, 1, 2. And typically 3 points is plenty. So let's go ahead and graph that line there. That's a little off. That's a little better. There we go. Alright. Now on this next one, you'll notice that it is in fact not in slope-intercept form. It has 4x equals 3y minus 3. So the first thing we have to do is we have to solve for y. Which means I need to add this 3 over to this side. So I would have 4x plus 3 equals 3y. And then I would divide both sides by 3. So this is going to leave me y right here, right? And I'm going to put that over here, kind of flip-flop sides. This 4x and this 3 are both divided by 3, so I can write them individually. Recall we went over this in the last unit. 4x divided by 3 is 4/3 x, and plus 3 divided by 3 would be 1. So now I know that my slope is 4/3 and my y-intercept is 1, therefore I've got a point at 0, 1. So let's go graph that. A point at 0, 1 is right there. If I use the slope to go up 4, 1, 2, 3, 4, and over 3, it's right in there. Or I could go, remember, 4/3 is the same as -4 over -3. I could go down 1, 2, 3, 4, and over 3, and left 3. That's the same as going up and right. Down and left is the same as going up and right when it is in regards to slope. So I'll go graph this now. And it's about right, and you can see those lines are coming together. They're getting closer there, right? They're spread apart here. They're getting closer up here. They are eventually going to intersect. We'll get into some of that later on, but it's good to notice those things as we go. Okay, so that's the graphing. We're going to talk a little bit about writing these linear equations now. First thing we need to take into account, given the slope and the y-intercept, we are going to simply use the values of slope and the y-intercept to write the equation. This is about as easy as it gets. So literally, if they give us this information, we simply need to plug it in. So if the slope of a line, for an example, if the slope of a line is 3 and the y-intercept is 0, -2, I want you to write the equation of the line. why don't you guys take a minute and try to do that on your own. Alright, hopefully it didn't take much more than a minute to figure this out. The slope is 3. My b value, or the y-intercept, is -2. Therefore, when I just plug that into the equation, the slope-intercept equation of a line, y equals mx plus b. If I'm adding a -2, I am subtracting 2, right? Awfully easy when they just give you the information needed. Okay, another option we may have here is if we are given the slope and a point on the line. So now we've been given some point, but it's not specifically the y-intercept. Okay, so there's going to be a couple steps here. First of those being, we are going to substitute the slope and the point into the equation, and then we're going to solve for b. This is a very easy step because you've got one unknown. Everything else is just numbers you're plugging in and solving algebraically. Okay. After we then find b, then we will have the slope and the y-intercept. We'll substitute that slope and our newly found y-intercept into the equation, and we will be done. So an example here. Write the equation for the line with a slope of 4 that goes through the point 6, -3. So it gives us a slope of 4, and it says that we have some xy value or ordered pair that is 6, -3. So what we're going to do is we're going to take this equation of a line and we're going to substitute in things that we know. Do we have a y value? Yes, in fact we do. It's -3, right? Do we have an m value? Yes, we do. It's 4. Do we have an x value? Yes, we do. It is 6. Do we have a b value? No, we do not. That would indicate that's what we're going to solve for, right? So -3 equals 4 times 6 is 24 plus b. Whoops. What would we do to solve that? We would subtract the 24 over to this side to get -27 equals b. And that's the only thing we didn't know in order to be able to write this equation of this line. So m equals 4. It was given to us. b equals -27. Therefore now I can write the slope-intercept of this line, which is y equals, we need the slope, and we need the y-intercept, which is -27, and that's the equation of this line. Notice, when I write the final equation of a line, I always have the y and the x in there. I was able to substitute this value in for those values in order, or those variables, in order to solve for one of the variables that I needed. However, when I write the final equation, do not leave the 6 and the -3 in for y and x, because the whole point of this equation, as we'll find out, or as we'll discover here in a little bit, in a few lessons, is that I want to be able to write this or graph this line. I want to be able to plug in different values for x and y. If I have numbers in there, I don't have an equation that I can work with. Okay? So let's proceed here to the following page. So we've learned 2 ways to write the equation. We're going to learn a third way when we're given even less information, when we're just given 2 points. So you'll notice now the 2 things that I need, slope and y-intercept, I have neither one of them. So let's go find them. If I have 2 points, I should be able to find the slope. And once I know the slope, I'm in the same position I was the last example, because I've been given 2 points and now I know the slope. So I can use the slope that I just found and one of the 2 points that I was given, and I can go solve for b just like I did in the last one. And then that last step is the same as the final step of the previous example. I'm going to substitute that slope and our newly found y-intercept into the equation, and I'm done. So the first thing we need to do here says write the equation of the line that passes through these 2 points. It goes through 1, -2 and -3, 5. When I'm writing the equation, I need to know the slope and I need to know the y-intercept. Well, if I have 2 points, I should be able to find the slope. Remember, always think of slope. It is rise over run, right? If you forget which goes on top, if you just remember rise over run, that should help you remember that the rise is up and down. Well, those are my y values, so that represents my change in y. The run represents my change in x. Okay, so it should kind of come back to you now. Remember, to find the change in y, you take y2 minus y1. Change in x, x2 minus x1. Well, let's plug in. y2 would be my second point over here, a 5, and minus y1 would be a -2. Be careful here, because I am subtracting a negative, which you should know ends up being positive. x1, -3, minus x, or I'm sorry, that was x2. I apologize. x2 was a -3 minus x1, which is 1. Well, that gives me a +7 over a -4, which you can leave like that, or you can put the -7 over 4. You can put the negative out front. So that tells me that my slope equals -7/4. And now it's just like the previous one. Because I know the slope, -7 over 4, and just pick one of your points. To be quite honest, I'm going to pick 1, -2, because they're smaller numbers. But it does not matter. You could use -3, 5 and get the same answer. So let's go ahead and plug in. We're going to find b now, right? We're on step 2. In order to find b, we're going to plug in values. Do I know a y value? Yep. Do I know an m value? Yes, -7 over 4. Do I know an x value? Yes, it's 1. Do I know a b value? I do not. So now what I've got to do is solve. So -2, -7/4 times 1 is just -7/4. So to get that away from the b, think to yourself, what am I going to do? This is just a number. I know it's a fraction. Don't let it scare you. It's just some number that I have a negative value of. Therefore, to move it to the other side or to get rid of it over here, I just add it, right? So add 7/4. Add 7/4. If you're uncomfortable with the fractions, just type in your calculator. -2 plus 7/4. Okay, that's what they're for. It should give you -1/4. Oops. Equals b. So now I have m and a b value, so I can go down here and write y equals, remember that's where my m goes, mx plus b, so I would subtract 1/4. It's simply a matter of substituting in these values. Okay? Alright, we're going to go to our last slide of the day before you get to work on your practice problems. And that's going to address parallel and perpendicular lines. A pretty straightforward concept, a concept I know that you've seen before. you should be able to answer this. Parallel lines have what? Have the same slope, which is what we've indicated here. The slope of the red line is equal to the slope of the green line. What that means, if things have the same slope, they will never intersect. Okay? These just keep going. They never get closer. They never get further apart. They never intersect. Okay, so when we're looking at this example over here, then it says write the equation of the line. Now, this is a symbol for parallel lines. Okay, two lines, two parallel lines right there. So the line parallel to this equation, this line that goes through 4, 6. So here's what we'll do. I know if this line, this new line is going to be parallel, that it's going to have the same slope. So the slope of that parallel line is going to equal 2, right? Well, I know it goes through this point. I know it has a slope of 2, so I need to go find the y-intercept. And as we've done in the last 2 examples, we plug in. Here's my y value, so 6 equals, here's my m, here's my x, so times 4, and then I'm looking for b, right? So 6 equals 8 plus b, subtract, and negative 2 would equal b. So now I know m and I know b, therefore I can write the equation y equals 2x minus 2, and that would be the equation of the line that is parallel to this line and that goes through this point. And those are parallel lines. Now let's look at perpendicular lines. Perpendicular lines, you'll see, form a 90-degree angle right here, right? Well, obviously those slopes aren't the same, but they do have a relationship. They are what are called negative reciprocals. And what a negative reciprocal is when you take something times something else and you get -1 for a product. For example, 3, the reciprocal of 3 is 1/3, right? So the negative reciprocal of 3 is -1/3. So in order for lines to be perpendicular, if this slope was 3, this slope would have to be -1/3. Or if the slope of one line was 2/3, the slope of the perpendicular line would be -3/2. Okay? So you flip the fraction and you make it negative in order to get the slope of a perpendicular line. So a quick example. The line perpendicular, this is the symbol for perpendicular, to y equals 2x plus 3 that goes through -2, 2. So we're dealing with the same original line as we were over here, but now it's going through a different point because it is going to be perpendicular. Same procedure. Okay. The slope of the perpendicular line, well, what's the reciprocal of 2? The reciprocal of 2 you should know is 1/2. So the negative reciprocal of 2 is -1/2. And now I'm going to do the same procedure here. I'm going to plug in values. So I have y equals mx plus b. My y value is here. My m value is here. My x value is here. And I do not know what b is. So solving, 2 equals. A negative times a negative is going to be a positive, right? And what is half of 2? Pretty easy, that's 1. So when I subtract 1 over, I get 1 equals b. So now I know the slope, and I know b. So y equals -1/2 x plus 1. And that is the equation of a line that would be perpendicular to that line and goes through that point. Okay, so what we're going to do in class is some inspire activities, some graphing on our calculator, and then we'll work on our 3-2 practice problems, and we will see you in class.